All right. So recording is on.
Awesome.
And we'll just wait another second or two, and then I'll do a quick introduction, Alex, and we'll be all set.
Sounds great. Thanks, Brent.
I'll put myself on video off, and Nikos keeps. I can see Nikos on there.
Here, I think I got him. Maybe.
I got him. He's been promoted to panelist. So Nikos, you're getting promoted to panelist. I think. There we go. Okay, welcome, Nikos. Nikos is promoted to panelist. He is the co-author on the paper with Alex. So, Nikos, if there's any hard questions, Alex has said he wants you to answer them. So you can keep your camera off or on whenever you want. I'm going to turn off here in a second. Well, I would like to welcome everybody here to our webinar for the Department of Agricultural, Environmental, and Development Economics in the College of Food, Agriculture, and Environmental Sciences at The Ohio State University. It's quite a lot of stuff to say. We have with us today Alex Hollingsworth and Nikos Zero-Giannis, who will talk about excess emissions, environmental impacts, health effects, and policy debate. I'll turn it over to them in a second, but a few general things to point out. We have one more webinar in our webinar series this spring on June 5th. Margaret Jodlowski will be with us talking about agricultural labor supply and citizenship status. That'll be the last one for our spring webinar series. We'll begin again in the fall in September, and we have a fun sort of group of people who are going to talk with us in the fall. Topics that we'll be talking about are going to be is using wood sustainable? We'll talk about that. Dr. Brian Rowe is going to talk with us about the role of some of these weight loss drugs on the demand for food. Amy Ando is going to talk with us on a really cool study about bats and how important bats have been for insect control in the agricultural area and actual evidence for the impact of that. And I believe Abdul Sam, if we can find a great time for him, it's a little tough sometimes, but he'll talk with us about some really interesting work that he's been doing on waste dumps and actually revenue generation of waste dumps from methane recovery, methane emissions. So we'll have some interesting talks in the fall. Look forward to those. But let me turn it over to today's talk. We're really pleased again to have Dr. Alex Hollingsworth with us. Dr. Hollingsworth is relatively new to Ohio State. I believe this was your first year here at the Ohio State University. I know you spent some time here before, but prior to coming here at Ohio State, he was at Indiana University in the O'Neill School of Public and Environmental Affairs, where he was sort of on the faculty from 2015 to just last year. So he joins us from there. Prior to that, he got a PhD in Tucson at the University of Arizona, PhD in economics. But most importantly, prior to that, he got his BS and BA from Miami University in Oxford, Ohio. I forgot to ask, are you an Ohioan?
Yeah, I mean, I grew up in Ohio, so I guess
Okay.
I was born in Iowa, moved here when I was like 3. So,
Well, I don't know. There's almost the same letters in both of those, except
yeah,
for
just one of those middle states,
that's right, 4 letters in each and easy to
Yeah.
say, very similar sounding. Well, we're happy to have you here back in Ohio, and hopefully for a long term in Ohio. Alex, I'm going to turn it over to you. Just one actual quick other question or comment for folks who are online. If you have questions, everyone's been muted. However, go ahead and put any questions you would have in the chat feature or in the Q&A. We'll kind of keep track of those and talk about them. Alex, if you see them on there and you want to jump in there at any point, or Nikos, if you do, jump in there, or you can save them to the end, up to you. And I'll poke people throughout the webinar and just remind them to sort of send in some questions. So over to you, Alex. Thanks for joining us.
Perfect. Yeah, thank you so much. Really appreciate this. Everybody being here today. Talk about some work Nikos and I have been doing for a long time. So just a little bit of let me switch the screens here. A little bit of a disclaimer. Basically, anything you see here that's any good, probably Nikos was the person that did it, or David. So the the rest of it, if there's any mistakes, it was probably me. So this is a result of many papers that we've worked on together. David Kaniski, Nikos Zero-Giannis, and myself. In the same title of a paper that came out last year in the review of environmental economics and policy. And so please just jump in, chat, ask any questions throughout this. I'd be happy to answer them. Before we get going, I just want to kind of frame our idea of like what's an excess emission. It's kind of a weird term. It's not my favorite term when we talk about this, but it's like the legally correct term, which is why it's in the title. And what it's not is it's not train derailments. It's not any pollution at all, but they're actually closely related enough that I think it's helpful framing for what we're talking about here. So, as many of you, with some connection to Ohio are aware here, this is a picture, an aerial photo from the vinyl chloride explosion and train derailment that occurred in East Palestine basically a year ago in February of 2023. It produced these sort of like post-apocalyptic crazy images like this that made national news. It was really salient. People were very aware of it. And to this day, there's all sorts of conversations about like, is it safe? What's the effects of the exposure to these pollution? People are rightfully very concerned. Even tests like nearby that showed maybe there's not unsafe levels of this. There's this huge toxic plume of smoke moving through the air. It's obviously going and being deposited somewhere. So today's not going to be about train derailments, but it's going to be about kind of similar events. But hopefully by about the midway point through this talk, you'll be convinced that these are more common and less salient than you would think. And so even though I'm not happy that this event occurred, but I'm happy that a lot of media attention surrounded the event conditional on it occurring. Most of these types of events don't get very much media attention. Here's another one. Here's another pretty salient one. You might not be as aware of it, if you're from the Midwest, but it was pretty big. And I'll show you another photo of this too that'll just really stress how large it was. This was in 2019, and this is the ITC fire, is how it's known, or the Intercontinental Terminals Company fire. And it's basically a bunch of these holding tanks. There was some kind of accident there where it caused them to catch on fire. There's a lot of gasoline in some of these tanks. And we were lucky enough that we were able to get in touch with this guy, Josh McMillan, who was just like leaving Houston on a plane. This is some like normal guy in an airplane. And he took this picture on his iPhone. And so here's the point. Like, this is the same spot right here. This is over here on the left where the ITC fire is. And you can see here, there's this big black plume of smoke. And if you squint, if the brightness on your screen's up enough, you can see right here under this plume of smoke is the entire city, like the downtown area of Houston. So this is a huge area that's sort of being affected by this fire. And this is very salient. There's not many other clouds in the sky. It's really obvious to see, where there's exposure. And I've marked here on the map sort of the distance in kilometers, but also the location of this circle air pollution monitor that Texas has and this triangle one. So before we even start talking about like the policy or anything today, I just want to give you like some idea of how bad these events are. So these are the same circles and dots representing the locations right here of where those pollution monitors are relative to where that big explosion was. And this is just like the level of benzene in the air at those monitors up until boom, when that explosion happened, when that accident occurred. And you can see that there's this huge change in sort of the underlying air quality. Not necessarily in every pollutant. It's not as like obvious for ozone here, although, after some statistical magic, I can show there was an effect, but it's like, you don't need any kind of training to be like, wow, there's a lot more benzene in the air than there was before. And benzene is not something you want to get exposure to. So after this event, the EPA stepped in. They had a shelter in place order. People were pretty concerned about the level of benzene in particular, but some other enes as well, exposure for people. And a lot of sort of attention was focused on this particular type of event. And there's all sorts of other pollutants and things that saw large increases as well. But these events, they're not always in making national news coverage, right? So here's one that made sort of local news coverage on ABC. As Brent mentioned, I used to work at IU with Nikos, but for a while I was living in Columbus. So on some evening, I think it was like April 14th, hilariously enough, given the title of this, on April 14th, I was driving back to Bloomington from Columbus. This is on I-70. This is sort of right at the Ohio-Indiana border. I see this huge plume of smoke. I'm like, what's going on? I see it for many, many miles. And I find some sort of local news show or story that says, hey, this thing has been contained. Don't worry about it. And that was a day earlier. So it's just a large amount of pollution from sort of an industrial accident. Just a couple weeks ago, my kid's daycare was closed here in Columbus. Many of you in Ohio probably haven't even heard of this story because a truck with a bunch of lithium-ion batteries caught on fire, sort of in Franklinton, and a bunch of places within a mile or so of there were told, you shouldn't even be at work today. It's going to be so bad to breathe in these fumes. So that's a great outcome. That, I mean, I obviously wouldn't want this truck to catch on fire in a counterfactual world, but it's great that like police, like the Columbus Police Department, was going around and notifying people of this. But it's very rare that this type of notification would occur. What's way more common than even this last one is something like a lightning strike causes a power outage at a refinery, and then some pollution control device is now offline. And so for the next, number of hours, 1,300 tons of SO2 are emitted. No fines assessed necessarily. This isn't, not every single accident is the fault of an operator, but there's a lot more events that occur like this every day. So for everything that makes national news like this, or even a little bit of local news like these two things, there are things that make exactly no news coverage at all, but still release quite a bit of pollution. And importantly, not every one of these events necessarily has a big black plume of smoke that's really obvious from miles away. Sometimes it's sort of invisible or not as obvious, we should say. There's different levels of like opacity is the word that they use. Here's another example. And again, this is in Texas. They realized in November that since April, so 7 months, there's been an issue with some of their pollution control. And so an extra 2,000 tons or so, it's sort of an imprecise estimate of SO2 have been emitted over a 7-month period due to a malfunction, right? So this wasn't like some act of God lightning strike or some explosion that couldn't have been prevented. This is just there's some malfunction, and some of the pollution control devices weren't working at these industrial facilities. And so to really focus in the framing, and not everything that I showed in those pictures before, those last two were certainly in there, is an example of an excess emissions event. What an excess emissions event is, it's basically something from an industrial facility, right? So we might personally be interested in things like, in semi trucks filled with batteries catch on fire, or the East Palestine derailment. But I'll explain why in a moment. We're going to focus in on industrial facilities. So we might be interested in all of them, but the set of data sort of we have available to us is just on industrial facilities. And really importantly, the excess emissions are distinct from like the regular emissions of like a factory. So if you think of like a place that generates electricity from like coal, sure, you might get pollution. That's a byproduct. You get electricity and you get some pollution, but there's some expected amount of pollution. Like, yeah, we want that energy. Sure, some pollution comes with it, but it's a good thing that we get the energy. The excess emissions bit wouldn't just count the pollution. It's not saying, oh, there's some pollution. It's saying extra amounts of pollution that are above and beyond sort of what a facility is allowed to be doing. So this might say like, well, we can have this power plant if it has these certain pollution control devices on it. And an excess emissions event would be like, we turned off all the pollution control devices because, the power went out to them. And so we had a lot more pollution than we should have, quote unquote. And you can immediately start to see why it gets kind of thorny to figure out like if a facility should be at fault when one of these events occurs, or if it's just truly an accident and there's some, underlying chance of accident. So there's just going to be some non-zero number of excess emissions across time. And this kind of gets at some of the core of some of the stuff that we're interested in, is how much of this is preventable and how much of it is just, sort of cost of doing business. So we've got a large number of papers sort of on this topic, some of them in economics journals, some of them more like general science journals. Nikos has really sort of led the way on this with David. So some of them look at pollution. Some of them just look at like describing how often these events occur. Some of them looked at, well, who is exposed? Some of them look at the policy environment. And I'm going to try to do my best in the least boring way possible to summarize sort of what we found from doing all this work. But, I love this phrase that economics is, common sense made difficult. So, danger, an economist is explaining something. I'll probably make it somewhat boring. I'll try not to, though. At least I started with big pictures of explosions and things. So, why should you care about this? Well, first of all, just themselves, I think excess emissions are kind of important. Like they're really frequent. They're pretty large when they occur, and there's not much regulation around them. Given the amount of given the amount of the regulation that around like the national ambient air quality standards and, really big like Title V facilities and things. This is one area where there's just not as much regulation. And I think our work has documented pretty clearly that they occur frequently and they have big effects on pollution and health, specifically mortality. And then, kind of more importantly, like we don't actually know that much about where they occur, with the exception of the state of Texas. So Texas has like excellent information on these, when they occur, how big they are, what pollutants, excuse me, were involved. But places like Ohio and Indiana and like other states where they definitely occur in, there's just really not like a big database where you can keep track of them. And all the big databases that we use to try to keep track of like, well, how much pollution do we actually get exposed to? Like the National Emissions Inventory, up until very recently, excess emissions were definitely not counted in there, and it's not even clear to me moving forward how they'll be counted moving forward. And then again, I mentioned this: the policy environment sort of in flux here. So there's no shortage of legal loopholes or different boxes one can check on a form when you say, oh, well, excess emissions occurred from my facility, but like, hey, nothing I could do about it. And there's like quite literally like a box you can check. And if you check that box, it like literally will change the way you could be prosecuted or fined if one of these things occurs. And so today will be a little less about like the legal landscape around there, but I promise you it's a very interesting legal landscape that involves like lawsuits from the Sierra Club, the Trump administration, the Biden administration, like different EPA regions sort of moving back and forth on this. And I didn't put it as a screenshot earlier, but like we also wrote, Nikos wrote mainly a public comment to the EPA when they were talking about changing some of the rules surrounding these. And then sort of a more second bigger picture reason why you should care about this is it's actually like, despite the fact that we might know like, hey, pollution is bad, um, just how bad certain types of pollution are is really hard to know because pollution is not randomly assigned. So I know many of you are more interested in agricultural yields. It's certainly the case that like a bunch of pollution exposure to crops is bad. But it's one thing to be like, oh yeah, I wouldn't like that. But it's another thing to know like, well, how bad is it? Or how much would it affect this? Because then you might need to know like, well, is it bad, but not enough where I would actually care? Or is it really bad where we should be like changing the way we do behavior through like fines or taxes or outright bans on some things, if it's like quite bad. And for instance, that's the case we've gone with like lots of lead. Like we don't use lead in gasoline anymore because we think that the consequences of using lead aren't worth sort of the benefits for less likely to have reignition in the engine. And so it tells us here, a little bit about some of these other under the radar pollutants and exposures. So like Nikos and I have now been doing work on like concrete batch plants and other sort of similar-ish sources of pollution. Let me just check the chat here. Okay, great. It's just Brent making sure everything works. All right. Okay, so let me just give you just a little bit of background. Some of this is mostly just exists in case you are interested in excess emissions or this type of legal landscape. So you have like a jumping off point to look at other things. But the basics of like air pollution regulation in the US is there's this federal legislation, the Clean Air Act, and that different states have to submit these state implementation plans to say, well, how will they meet their Clean Air Act requirements? And there has been some, to put it charitably, back and forth, and some states have presented it as unclear as to whether or not excess emissions, how they should be characterized within these state implementation plans. And the EPA basically said, hey, states, those of you that are not counting excess emissions events as essentially violations of the Clean Air Act, you need to go back and revise your state implementation plans. Then there was some back and forth between the Trump administration and then when the Biden administration came in about this, about exactly how this would be handled. But it's sort of a complicated regulatory framework. Because as you'll see, as I sort of show some more data here, it's not like this is like a one-off event that has a very low probability of occurring during a facility's lifetime. So the emitters, the polluters themselves, have sort of a large incentive to decrease any regulatory burden surrounding these, because it's somewhat likely, in particular, like some industries like refining, oil refining, that these are going to occur over or any time period. Okay, so like we're in the Midwest. You might wonder like, why is like all this research you've been doing on Texas? I alluded to this earlier, but like Texas just has awesome data on so many different things. So the Texas Commission on Environmental Quality, the TCEQ, has this awesome air emission event reporting database. And essentially what it is a big, really easy to access, really easy to read database on the internet that's publicly available 24 hours after an event occurs with information about the event, and that's updated across time. So, like this is the Intercontinental Terminals Company fire that occurred in Deer Creek, the one that I showed you the picture of earlier. Here's the one that was like put forward sort of like right after the event occurred. It said which tanks were involved. It gives information about how long the event was. So you see, it happened for a very long period of time. So after it occurred, wasn't like after the start, but sort of after the completion of the event, a 4-month period. And it gives all sorts of information about like the pollutants that were released during the event. And of course, there's going to be a large amount of guessing, for lack of a better term. It might be informed guessing or not, because it's not like we have perfect sensors on every single tank that explodes. But they do their best to try to figure this out. So in some sense, this is a bit self-reported. Some of it comes from modeled estimates, but some of it is from sensors as well, right? So in some cases, you'll know like oh wow, I know exactly how much was in this tank, and if it were to catch on fire, how much was released into the atmosphere. And some of it is more it's not uncommon in these data to see something like 500 pounds was released, like an order of magnitude guess, but it's still better information than nothing. And then a really cool thing as well that we make use of in some of our papers is there's some text descriptions about the event that occurred. And that allows us to say like, well, was it due to like hurricanes coming in? This is a really common thing in Texas, like a hurricane showing up. Hey, we got to turn off the power plant and we got to turn off fast. And maybe that means turning off the emissions control devices more quickly. So sure, that's an excess emissions event. Excuse me. That's maybe an okay one because you'd really rather have that plant turned off rather than operating at full capacity when like a hurricane arrives. So this sort of allows us to do a little bit to disentangle like, hey, are these necessary? Are they unnecessary? What's going on here? And in short, we end up with this like very large data set of a bunch of different excess emissions events with a bunch of different pollutant releases, all in Texas, essentially from the year 2000 to like last year. So it's a lot of really detailed information about, for lack of a better term, you just think of these like industrial explosions and malfunctions and pollution that comes out of those. And just to give you an idea here, I said earlier, like, hey, this stuff like the East Palestine train derailment, that happens all the time. Where's my support for that statement? Well, here's just a number of facilities. That's the dashed line that have an excess emission event in Texas in any given year. And so again, this isn't like trains or semi trucks. This is just like, think of it as like a physical facility in one spot. But you see, like it's about 500-ish facilities a year have some excess emission event, or at least one in any given year. And then there's a lot of events that occur. So among those, 500 or so facilities, there's like 3,000 or so events that occur in any given year. And these aren't like, oh, wow, 1 pound of SO2 was released on average. On the average day in Texas, there's one event that releases 10 tons of emissions. There's 3 events in the average month in Texas that release 100 tons of emissions. And there's about 3 events per year that are more than 1,000 tons. So you can see there's a lot of large sort of scale events, and not all of these are getting national attention, even though they might be having sort of similar health effects. And in fact, you could start to think about, the one that gets the biggest news media attention might have less health effects because people are able to sort of leave the area when it's occurring. But if something's sort of happening and no one's knowing it until after the fact, and there's not some big black plume of smoke around there, it might have even greater health effects. You might be wondering, Texas is a unique space. There's a lot of, particularly in West Texas, extraction of natural resources that occurs. So is this even happening in populated regions? And it's definitely true that like where there's more sort of industrial activity, you're going to be more likely to have these excess emissions. And there's some version of industrial activity where there's natural gas extraction. But it's also happening in, Houston and Dallas and other places where people live as well. So this is the number of excess emission events that release more than 1 ton of pollution in 2013 by county. And so you can see like there's a bunch of counties where there's more than 30 events in that year in just 2013 where there's more than 1 ton of pollution released from a single event. This is kind of hard to read. This one, I kind of wish I would have remade this here. This is for a paper we did a long time ago. But the basic point of this is most of the events that happen are these big events. But there's a lot of these tiny events that happen as well, where there's these sort of large, more than 1 ton of releasing. A not too trivial point, though, is also that if you just compared like a power plant or a refinery and you looked at like, well, what's like a regular sort of cost of doing business pollution that comes out of that industry? Where do these excess emissions fall relative to sort of that cost of doing business pollution? And for some industries and for some pollutants, I mean, they're a pretty huge share, excess emissions of pollution relative to routine pollution. We're talking, uh, it might be 17% on average, I think is the number for refineries. And I've actually, the 17% might be across all industries, and it might be even higher for refineries. But it's not like it's a drop in the bucket. Another reason to care about these things is, this is mostly just a mechanical reflection of like where industrial facilities are located. It's not like I want you to think these industrial facilities are like, we should have more accidents in these areas. It's just that they tend to be located in these areas and they tend to have accidents. It could definitely be the case that they are more likely to be more likely to have accidents in certain areas than others, but that's not something we've directly explored. But these excess emission events are more likely to occur to people that are already marginalized on some dimension. So they're more likely to occur, at least within the state of Texas, where we have the data, in areas where a lot of people rent, in places where the houses are cheaper, where people have lower levels of education, where there's a higher percent Black, higher percent Hispanic, lower income. So it's just in areas that are sort of already hit. And just to give you some idea here, these are all from Nikos. He went to Houston to work with Airlines Houston, and this wonderful person there who used to be affiliated with them, Bakia Nelson. So here's Houston. Here's basically a bunch of the refineries in Houston. A lot of them are located right here off of the canal, but it's not just an area where only refineries are. Let's zoom in on this little box right here, which is sort of where that picture just was. You can see an aerial version of that picture right here. If you zoom in even more to right here, this is a park. Okay, this is where like houses are. So this right here is a picture Nikos took of like where a person lives right next to all of these refineries, right? Or all these are actually holding tanks, but still, this is a park where kids play. This is Nikos met a group of children that live in this area who had painted a mural, and they weren't painting a mural to highlight pollution, right? They were just painting a mural of their neighborhood. And you can see like, here's where they live, here's where they play, here's the park, here's the shipping canal, here's the highway, and here is a bunch of industrial pollution from stacks that they can see, right? So it's just where these things are located when they have more accidents are going to be, this is the group of people that are getting exposed. So people that are already marginalized in some way. And that's an important thing we think to document as well in this setting. Okay. And another thing is, since we're economists, we're not just interested in being like, oh, wow, they occur here. And look, there was some event. We want to know, like, does it matter that the event is occurring? Because, again, if it's like, what's 2 pounds of SO2 versus 2,000 pounds of SO2? Is it meaningful that that this difference is occurring? And so we've sort of documented, hey, they're big, they happen all the time, they're large relative to routine emissions, they happen in these more marginalized communities. But do they affect, like, if I were to put like a federal regulatory monitor, like something that just checks like PM or ozone in a neighborhood, are they affecting the underlying concentration of like air pollution? So you can think of this as kind of asking the same thing as like, hey, I know I'm polluting when I drive my car, but does my car actually like change observably the air quality? So here we're saying like, wow, these excess emissions occur, but are they actually affecting like the underlying air quality? So it gets kind of complicated to study this because an excess emission event generally releases like lots of different types of pollutants as well. And the pollutants interact with the environment in different and complicated ways that I don't really want to get into here. But one of the things that we did is we basically limited ourselves to studying only the excess emission events that released things that are likely to cause ozone, and then just looked at air pollution monitors that are within like 5 miles or 10 miles or some just kind of reasonable distance from these ozone. Look at excess emission events that are within 5 or 10 miles of these ozone monitors. And we just said like, well, hey, when there's more excess emission events in a month, in a day, in a week, in a year, what happens to like underlying ozone levels? And here you can this is what we call an economics and event study. And I should have used a more high resolution version of this image. I'm sorry. But you can see here, there's basically like before the explosion happens, that's like -2 would mean like 2 days before the explosion happens. An explosion in the future doesn't change air quality today. So that's a bit of like a gut check, a placebo check. Like, does this seem to be kind of reasonable? Well, like, yeah, okay, future explosions don't change air pollution today. But then on day 0, meaning on the day of like the explosion, on the day of the accident, boom, you get a big change in ozone levels. And then the day after, they're still elevated pollution, and maybe the day after that. And then about 3 or 4 days later, you start to see, after the explosion, you start to see ozone levels return back to the average that they were ahead of time. So that zero shouldn't be interpreted as like no ozone. It's just kind of like whatever sort of the average ozone you'd expect in that county year. So we do a lot of other sort of more fancy, complicated stuff in a series of papers to just sort of link these excess emission events to pollution, but it does seem like they're changing pollution concentrations. And now what's neat, and I say neat as like a person who's interested in studying policy, but also sort of terrifying, is we can then link those excess emission induced changes in air quality. It's basically like, hey, these explosions happened. They made the air a little worse to be breathing, to health. And, it's going to change health in a variety of dimensions. It might make you a little grumpier, a little more irritated. There's a lot of work on that. It's actually, for any of you that are baseball fans, there's some cool work. We still use like human umpires in baseball. So, they call it balls and strikes. But then we also use computers that know whether it's a ball or strike. And so there's work that basically shows like when it's more polluted, umpires make more mistakes, right? There's other work that shows, in days where there's more pollution, people are grumpier. Other than sort of even more important work that shows like, hey, when it's polluted out, you get asthma, you go to the emergency department more, you're just a little sicker. We're going to study like an extreme version of that. Do more people die on days where the pollution is higher because of excess emissions? And this table's got a bunch of crazy numbers in it, but just the answer is yes. All right. And we do a lot of different things where we look at ozone concentrations using different measures. We basically say like, hey, when ozone increased because of excess emissions, what happened to mortality in those areas where the ozone increased more? And we show that like basically when the events were big enough to change like the average ozone concentration, like, wow, it really seemed to affect mortality quite a bit. And it really mostly affected mortality for old people, for the oldest people, excuse me, for people age 85 and above. There's sometimes we can get effects for like 75 to 84-year-olds, but all the effects are really driven by like a large class of volatile organic compounds being released from these facilities that induce more ozone, that increase elderly mortality rate quite a bit. And a way you can sort of just like turn this into an English sentence rather than some weird complicated table is a 10% change in the average ozone concentration. We would expect to increase elderly mortality by about 4%. And so this is sort of that second reason of like, well, why should you care that I gave earlier, is this isn't even just about excess emissions. This is just allowing us to use excess emissions as sort of like a natural experiment that changes the ozone concentrations in an area to sort of trace out, well, what's just the damage? What's the relationship between ozone exposure and elderly mortality? And then there's people make all these kind of complicated models where you can just turn that into dollars. This is why, my students always struggle with economists. We're like turning lives into dollars so we can compare it to like building damage or lost forests or other things. But it is one useful way to sort of compare things that are not in the same unit initially. And it's something like, 150, $100 million a year in damage in just Texas from excess emission events alone, just from our model. So we think it's actually probably much larger in reality. But this is all sort of using stuff that biases us away from finding an effect. So, all right, just to sort of move forward here for policy recommendations, I can take questions throughout. The REAP paper, the Review of Environmental Economics and Policy paper that we wrote on this, tried to sort of highlight, well, what did the Trump administration say? What did the Biden administration say about these events? What's the EPA say about these? And one of the things we tried to highlight were these complicated sort of regulatory loopholes. And I'm using the word loopholes today in the presentation because I think it's actually like more descriptive of what they are. But you'll see things like affirmative defense is the language we use in the paper. That's the kind of stuff I'm talking about here. So we just try to talk about like, well, what's the sort of like suite of things that are available to policymakers when they're trying to like, punish those who have excess emissions that are deemed to be like sort of not accidents. And we try to walk through that in that paper in some detail. But then we also try to offer some constructive feedback because we're not like lawyers. So the feedback from us, maybe they need feedback on how the law is written, but that's not something we're going to be able to do. Our feedback's pretty simple. We were saying it would be really nice if other states were basically required to report and keep track of these excess emissions events the way that Texas does. In some very like technical sense, every state is supposed to be keeping track of these, but I forget which state off the top of my head. But like Nikos did sent FOIA requests to like every single state asking for them. And a couple states were just like, no, we're not going to comply. And a couple other states were like, well, sure, we could comply, but it's like a pile of papers under like Jim's desk. So there's no way we could actually give it to you. And, Texas is really the only state that keeps track of and makes what they keep track of useful to researchers and policymakers, so we can get some idea of sort of how often these are occurring. And then for a while, it was also the case that they weren't even being reported as estimates elsewhere. And that luckily, like since we even made a version of these slides a couple months ago, has changed. And I think that they're going to be in the new national emissions inventory moving forward, but I'm not totally clear as to how that's going to be estimated or where the underlying data is going to come from. And then like another important thing is like Texas is a lot of people live there. It's a big state. It's got big cities in it. But a lot of the damages in Texas, a lot of the excess emissions in Texas were in West Texas, which is pretty low level of population. So like maybe it's the case that in New York, most of the excess emissions are occurring like in an area where like people that live in Manhattan are breathing them in. Or in Chicago, they're being affected by like excess emissions that happen in Gary, Indiana, right? We don't know, right? So that's a complete hypothesis, but I'm just sort of guessing based off where the industrial manufacturing is relative to the wind directions and population centers. So it could very well be the case that if you were to like redo versions of our analysis in non-Texas states, you get like way larger health damages just because of like the types of facilities and the types of accidents that they have are going to differ across space. So I think this leaves us, hopefully I was trying to leave about 20 minutes or so for questions with plenty of time for questions. Thank you very much. And really thank you to Nikos and David for all the work they did here that I was presenting. And thanks for Brett for organizing this.
Yeah, thanks, Alex. That was fantastic. I guess it raised a lot of questions in my mind. I want to invite everybody to who's on there to ask questions. Let me get myself on video again. But I guess I still struggle with the what are we to do about it? And
Yeah.
and the question really kind of comes up to me that I didn't detect that there was a big reduction in emissions or that Texas was somehow doing better than everybody else because all this data was reported. I mean, if the excess emissions typically is usually like an accident, if I understand it. Is that kind of one way to think about it?
Yeah. So I guess let me try to answer your first question first because it's the best. It's a very good one. We don't have a good counterfactual state, and so that was actually what Nikos started off trying to want to do was look at the state of Louisiana because they had recently started reporting excess emissions event, and I guess that's a good like dissertation project for someone to do probably like 5 years from now. Still, they're like the only other state that started to report them, but it was kind of too late to do any useful overlap. And so our hypothesis is that states that have good reporting will change what happens, but we don't know that because we don't have a good counterfactual. And then to answer your second question, we did this thing. I'm not sure if I have it readily available. I might be able to pop it up real quick here. That'll be a challenge to do while speaking. But if it is the case that there's just some underlying probability that's equal across all people, like it's like, you trip and fall at any given time, like who tripped and fell today, then the distribution of excess emissions across time shouldn't really have much relate. Like the same firm shouldn't always be showing up as like a repeat violator. And so Nikos and I did this cool thing. And it was just in the REAP paper, but I kind of wish we would have done it at the very beginning of the project where we just looked at like, hey, if you were like in the top 10% of the violators last year, what's the chance that you're like in the top 10% of the violators next year? And it's like a perfect straight line. It's like the firms that repeat in 2009 or the firms that offend in 2010, they're sort of the same firms. Again, that's not showing it's not an accident. So that's, it's not like I proved that, but it kind of it's another piece of evidence that like something unique is going on in these firms. And then another thing that we did, and again, it's incomplete, but we use those text boxes. We did it sounds fancier than it is, natural language processing. But basically we like looked around for like common themes of words. And we tried to pull out the ones that are like related to hurricane, lightning, fire, weather, flood, snow. Like in Texas, for instance, if it gets icy, it can be pretty problematic. Like a lot of those things weren't meant to handle sustained cold temperatures. And you can pull all those out and you're left with like 85% of the events. Nikos, please jump in too.
Thanks. And I can turn my camera on, but I am not able to. I've been disabled by the host, but it's fine. I just
sorry, my
no worries, no worries.
Yeah. I was like, what are you talking about? You're not able to. You're
don't
literally
have
not
to.
able to. My bad.
I'm happy to turn it on though. So one thing just to add to Brent's point about has there been a decline in emissions after Texas implemented this policy? It is not clear that Texas implemented this policy of reporting with the goal of reducing emissions. So this comes as a result of a series of memoranda that the EPA had published back in the late 90s, where basically it told states, look, states, we are aware that you have all those loopholes in your state implementation plans. And I'm using the word loopholes here a little loosely. But essentially, if you want to keep those loopholes in place, like affirmative defense, that's fine. But you need to be very clear that you are doing a good job in reporting and record keeping of those excess emissions. So essentially, Texas in 2001 developed this detailed reporting system so that it can then claim that, look, I have everything in place that the EPA has asked me for in order to be able to offer my facilities what is called affirmative defense, essentially offering them regulatory relief from civil lawsuits that citizens might file against facilities that have those excess emissions. So it's not clear that the goal of the policy was to reduce emissions.
And then because Nico saved me by talking there, I was able to like find this slide that he had made, which is basically like, here's how bad of an offender you were from the years 2006 to 2012, just by like where were you in the percentile among all industrial emitting facilities in excess emissions. And then this is a bin scatter of where you were in the next part of the data. So it's just like, it's a bin scatter. So it's masking some spread, but it's a pretty, it's almost a 45-degree line. And then you can see these slides look pretty familiar. These are ones Nikos made that I adapted for today. And then here's our thing that we did about the topics. We use those like text boxes to try to categorize things. And so it is true that like a lot of them were related to like weather, like act of God weather things. It's still like collectively they add up to be like 10% of the events. And then, you can get into questions like, did we categorize these all appropriately or what? We're not experts in natural language processing, but we did this before ChatGPT. So cut us some slack.
Were you able to sort of discern in terms of aggregate pollution where these kind of fit? I felt like you had a slide earlier, and I don't remember it, but it seemed like it sort of suggested, this is X% of the typical pollution that a person might receive in an annual year. And of course, I mean, I know it varies. West Texas was the big place, right? There's not a lot of people out there, but but still.
So I don't think we've ever tried to do it in the way that you're characterizing it, but that is really interesting. And I like that framing. I've seen that. This is, again, not excess emissions, but David Maldor does a good job when he talks about like, hey, are wildfires a big deal? And they basically say that like X% of PM exposure is from wildfires. So we never even tried to do that, but that's a good thought. My guess is it's actually a pretty low share of total ozone exposure is caused by excess emissions, but we've never tried to estimate
the damages, right? In the sense that it's so unexpected that you almost can't even avert it when it happens, right?
Yeah, that's an excellent point. But yeah, from a damage standpoint, right, these unexpected things are nice because they provide like the unavoided. That's not the right way to phrase it, but like
well, it kind of is. I mean, it's like it's like in Palestine, East Palestine. Who could, I mean, there's an initial impact there that nobody was able to avoid. I assume, right, because they were there and it happened, and it was just not expected. Right? Whereas we have like the wildfires last summer, there was a bit of expectedness on that. Of course, it affected more people potentially, but you could avert it by sort of staying inside, and you knew it was coming. You had pretty good weather forecasts of that. So yeah, it's interesting. I mean, I just wonder if there's also sort of a how this fits in with the trade literature too on sort of the race to the bottom idea, right? And the idea that if you don't have a good regulatory structure in place for things like this, excess emissions are companies that are more susceptible to this, all heading to Texas or Louisiana or Ohio or wherever it is, right? I mean, if you would want to have I mean, if it's a weather event, okay, I get that. But then again, you want people to take advantage of it. Texas happens to have a lot of weather events that cause this. And so that why all these polluting firms are moving to Texas because if there's something bad happens, not on me, on the weather.
Yeah, and I want to be careful how I phrase this because I don't want to like frame all the firms as being like, awful or something. But basically, there's this box, and it sounded probably like I was being cavalier, but on the form, when you like fill out, hey, we had an excess emissions event, and if you click this box on this digital form, it changes the burden of proof. Now the state has to prove that it was avoidable, right? It like flips. It basically makes it like impossible to prosecute. And it's not like you have to, in order to click the box, you have to like jump through 7 other steps. You just have to be like, yeah, I say it was unavoidable. And now you have to prove that it was avoidable, which is a very high burden of proof. In the state of Texas, actually even changed. Actually, Nikos, I don't know if they changed it, but they floated some language that might have been changed, which was saying that in order to penalize one of these firms, you need to prove that they violated the National Ambient Air Quality Standard. And now that might sound to someone that hasn't ever read the National Ambient Air Quality Standards because you're probably a normal person, like, oh yeah, that seems fine. You need to prove someone committed a crime before you punish them for it. But the National Ambient Air Quality Standards are complicated. So it's something like the average of the 4th highest maximum value of ozone over a period of time. It needs to not be above 70. Well, like showing that like one single event caused the average of the 4th max value to be this, like you like literally show like you've already limited yourself to a set of locations that were almost going to be out of compliance. So there's almost like no locations that were just barely not in compliance that could have been triggered into the sort of bad status. And so I don't know if it was like clever on their part to write it that way in order to make it so that no one could actually be punished, but it was it certainly appeared quite clever.
And just to follow up on this too, because I think Brett's point is an important one in terms of do we have a race to the bottom here, right? I think that's what the EPA has been trying to do, especially after 2020, is level the playing field by removing all of those loopholes and all of those automatic exemptions that facilities were getting in different states. And there were many states, in addition to Texas, that were offering those quote unquote loopholes. And as of 2 years ago, EPA has gone through and said, look, states need to remove all that language from their state implementation plans, exactly to avoid situations where you might have a race to the bottom kind of situation.
Yeah, but if I've understood correctly, so a reason why you're able to do some of the work you've done in Texas is because you have to report this stuff, right? It's not reported in most other places. So we really don't even know the extent of excess emissions, right? I mean, that was kind of some of those pictures you showed at the beginning, Alex, were pictures, say, from Ohio, which would be considered excess emissions, but actually they're unreported, right? They just happened, and you happened upon them, basically, right?
Yeah.
So, yeah, I mean, has anyone tried to detect these from the air quality stations that are out there, to try to see if they can detect where these things happen in other places where there's not the good access to reporting that you have in like Texas?
I guess like the closest is fugitive methane, but I still feel like that's like guesses. I don't know, but I'm not as familiar with that.
That's definitely guesses, right?
Okay.
That's all like, satellite stuff basically now.
Yeah.
And just to clarify, there are states, so Louisiana, Oklahoma, they do a pretty good job keeping track of excess emissions. What they do not have is that 24-hour notification requirement and public notification that Texas has. Right. So when Brent asked earlier, like, can we do like a diff of, did this policy really have an effect in Texas? The problem is that, yeah, we don't have a similar setup of knowing exactly when those things happen in other states. But there are states that keep track of them. It's just that they don't make the data as available in the very user-friendly format that Alex described that Texas does.
Yeah. And like, I don't know if it's because of the 24-hour rule or not, but like the EPA did do a shelter in place order after that ITC file because of the benzene levels. So it could be, I mean, Texas has fantastic, they're not federal regulatory monitors from the sense for like Clean Air Act, but like a bunch of like air monitors that just are always keeping track of benzene and stuff around the city. And so like those were as I showed in that graph, just peaking after this thing. And so that might have been enough on its face to just have the EPA come in. And, you know, but they were like flying planes and driving buses around with like monitors and things looking for this. But certainly it was like this, it didn't hinder people's ability to learn about the event. If anything, it helped it. So,
Yeah. Well, so it makes sense there, right? Because there's such a concentration of industries in Houston, sort of between Houston and the coast, right?
yeah.
I mean, that's one of the major industrial corridors of the U.S., and so they would have to have all that sort of infrastructure there to capture, you know, benzene and other things. So there's a lot of chemicals being used there.
Yeah,
It's
Nikos
amazing.
went through a lot of effort. We got a grant. We got a bunch of low cost local air pollution monitors. We were like trying to make relationships with churches and schools in neighborhoods where there weren't the monitors to see like, hey, I bet they're actually getting hit harder, and we have like little data on it. But then COVID happened, and like this is we don't have the monitors anymore. The studies is not a thing anymore. So
Yeah. Well, I'm surprised someone hasn't studied that though. I mean, that seems like an important thing to look at because you have, like as you pointed out, there's plenty of neighborhoods that are in, you know, industrial areas, right? And you know, those neighborhoods could have been there for a long time, and there could be some long-term historical exposure to all kinds of stuff, right? That's completely unknown.
yeah. There's some people have studied versions of it, just not the excess. We wanted like the high frequency air pollution monitors because then we would know when the excess emissions events happened. But like one of our co-authors on another project, Gabe Filippelli at IU, he did something. I mean, it's really simple, but I think it was really informative. He just like had a bunch of people volunteer to take dust samples from their house in Indianapolis and just send it into his lab. And then he just looked at like who had more lead in their dust or from around their house, like sweeps up some dust from your floor. And it was, you know, neighborhoods that are by places that had historic uses of lead. So it's, you know, it was sort of, as you're describing, it was a different kind of measure. But
Yeah. Well, I probably need to be doing more of that actually, right?
yeah,
And especially in a place like, you know, in Houston where, you know, there are well, I don't know, could you think of in the Midwest here a similar sort of industrial, I mean, because at the moment, you know, it's sort of been deindustrialized. I don't know of any sort of concentration that would be anything like what they have in Houston, right? With respect to like there's a few refineries around, right? We know there's a few refineries around, but they're pretty dispersed here, right? They're not all in one place as far as I can tell.
yeah. I mean, Nikos, you seem like you got something on the tip of your tongue that I have an idea.
I would say that yes, there are all the oil refineries are definitely concentrated. You know, there's a lot in Texas, a lot in some in California, but there's a lot of ethanol refineries,
Right.
around
Those
the
are still
US.
kind of spread out though, right? I mean, they're not really like in
Correct,
one corridor.
but I would say there's a lot more of them in places like Iowa or other Midwestern states that have a lot of ethanol.
And ignoring
production.
refineries, like I happen to just know only stuff about lead, but like Gary, Indiana has a plant that like releases the majority of like industrial lead emissions for the United States. And like when that wind is blowing to Chicago, it's not good. And that's not even excess emissions. That's like from the national emissions inventory, like routine emissions from like, I think it's smelting. That's what's going on there. But
Yeah, so that would be like the most. I mean, of course, they probably still do have what the U.S. Steel, something like that, still has an operation there.
yeah.
But yeah, well, that's fascinating.
Trash recycling in Indiana, and then actually here I can show you some other stuff. It's not exactly excess emissions, but this is I'm lucky enough to have so many different awesome slides Nikos made. So another thing we've been studying for a while has been these concrete batch plants, and so these like you just drive down the road, drive down Fifth Avenue, cross 33, and go up to the luxury apartment complex, and you'll be across the street from a concrete batch plant. And Nikos, I spoke too soon. I thought I had your slides up. But you can think of this as basically like direct, unfiltered PM to the face. I mean, it'll like cover the windshield of the cars from the places across the street. And we have that all over most cities in the United States in ways that are like, I wouldn't say inappropriately, like illegally filtered, but like from a standpoint of I'm a environmental health economist, I think not appropriately controlled emissions. Somewhere over here, I've got these slides with a bunch of locations of those.
Yeah, and so yeah, concrete production is pretty much all over the place.
Yeah.
Yeah, it's interesting. You know, we tend to think, isn't it true that we tend to think that the biggest damages come from these events with the really big smoke events, right, where you see the smoke, but the reality is it's the really small, fine particulate matter that sort of gets into our lungs that causes a significant amount of sort of health effects, especially for people who have asthma, pre-existing conditions, elderly, etc.
Yeah, I mean that's the stuff like I don't know. I've been really fortunate to work with Nikos for a variety of reasons, but like one of them has been Nikos and David are really good at establishing relationships with like communities, like people that live in certain areas. And so like I think Nikos, it's the correct characterization is like people that live in Houston, like Bakia, the airlines Houston, and the people that they know at the Sierra Club were the first people to like bring that concrete batch plant stuff to our attention. And since the more we looked into it, the more we were like, oh yeah, this is like a major source of like hyper local, very bad air pollution that's like not getting enough attention for the damages. It's like instead of spreading out the damages all across the city because you've got a big smokestack, it's just like pouring them onto like a very small sort of area that lives right by it.
And that's the big difference between sort of the setup that Alex describes with those concrete batch plants that are, like in Houston, there's like 130 of them. And each individual one is very small and doesn't emit large amounts. But the difference is that compared to like a refinery or a power plant that has a 300 or 400 feet smokestack, here we're talking about emissions that are released at ground level, right? So yes, they might not travel as far, but they are released right next to where people live, right next to schools, right next to hospitals. So the exposure is a lot more direct and less diffuse than releasing things at 300 or 400 feet height that can travel 10, 15, 20 or more miles and affect even neighboring states.
Yeah. Well, it is curious. Like Alan Lyons, asked this question here in the question and answer. He pointed out that he was a survivor of the Love Canal, which was the area in Buffalo, outside of Buffalo, where they put basically I mean, Alan, he put. I didn't know you lived there, Alan. I knew you're from upstate New York, but basically a community was developed on top of a historical, nasty waste dump with a lot of really nasty stuff in there. And it is the same thing with a lot of this air, these concrete batch plants or whatever, right? That you're talking about. It's the same thing. It's like it's kind of an unknown pollutant that's kind of next to us that we don't know anything about, right? It's a very similar thing to the Love Canal, right? Where we wouldn't have, no one knew it when they were building the plant or building the subdivision. It's fascinating. And maybe we haven't learned anything, Alan. I don't know. What do you two think, Alex? Your final sort of comments. What do you think? Have we learned anything or haven't we learned anything?
I feel like we've learned stuff. I just feel like we tend to think it's no big deal if it seems small, and sometimes that can be a big deal. And then also, Alan, I have a picture. I can't find it real quick of him pointing at a map, not even knowing who I was or that I was next to him, being like, "This is like the worst place to live because you think you have good air quality, but your air quality is actually bad." Pointing to like it couldn't have been closer to my house in Indianapolis from like a whole map of like the U.S. Like, so one of the things he's interested in is like when we think the air is good, but it's bad, essentially. And that's something that can happen here too, is we might have convinced ourselves, oh, the pollution, it's no big deal because it's not being reported, but we're then being exposed to all this other stuff. And I think we've learned less about how to bring stuff to the light, so to speak.
Right. Yeah, Nikos.
And for me, just a final thought that I agree with Alex that we have learned a lot about how pollution affects people. I think one thing that keeps surprising me is that somehow in this country and in other countries, we've just come to terms with the fact that the cost of doing business is just tens of thousands of lives lost every year. And we've just come to terms with that, right? So as Alex said earlier, we want electricity 100%, right? We want economic development. There is a cost that comes along with those things. And part of that cost is air pollution. And we've just come to terms with the fact that people are going to die from exposure. There are many things we could be doing better to decrease pollution exposure. We choose not to do them. And that for me is something that really needs to change. And in part, that's what motivates the work that Alex and I and David have been doing on excess emissions, just to illustrate the impact that they have.
Yeah, that's a great point to sort of leave on that, there's a lot more we can do on this area. And as economists, policy analysts, it's really incumbent on us to figure out the best policies to get there, right? And to figure out ways that you can advise EPA, or not so much EPA, but Congress really to implement regulations or whatever that would actually have an impact, that would actually benefit people's lives. This is weird stuff in the sense that, if you are in a car accident and, really the worst thing happens and someone dies, right? It's so obvious what the impact was, right? But with air quality, it's a decade later, it's down the road, it's not the direct impact, right? It's an impact born of, everyday exposures over a long period of time, right? And this cumulative stuff. And it's harder for people to get their minds around that, but it's something we need to get our minds around, right? And so in some sense it's harder to regulate. Anyways, preaching to the choir here, you guys. This is a fantastic presentation. Really appreciate you guys doing that. It's certainly a topic I haven't thought much about, and really learned a lot today, sort of hearing from the work that you've been doing. And I'll look forward to reading actually some of those papers. Even though Alex is a colleague of mine, I'll fess up to not having read all of his papers. So maybe I'll read one or two.
We sit around reading each other's
He's got too
papers.
many. He's got too many papers.
Yeah, maybe I'll spend my summer doing that. So thanks a lot very much to you guys for both joining us today. For those still on here, quickly, we do have one more webinar, Margaret Jadlowski on June 5th, talking about labor and citizenship. So Alex, Nikos, thanks a lot.
Thank you.
Thank you, Brent.
We'll stop the recording.
Sweet. Hey, Nikos, thanks for